So my name is Dejan. I work for Red Hat. I've been in Red Hat for many years, working different things, but for the last couple of years, I was focusing on software supply chain security. And as a part of that, we will see later on, the vulnerability management is one part of that. And digging through all the vulnerability management and vulnerabilities, it seems, yeah, straightforward at first, but then you discover a lot of different sources, protocols, standards, and things like that, and pretty quickly things get a little bit confusing, right? So I thought in this session to go through all these basics and things like that. So there will be a lot of acronyms, and we will explain, what things are, and hopefully, like next time, you are forced to look at some CVE because something is going on. It will be easier for you to read those data to figure out what exactly does this mean for me and how to proceed. And in the end, I will show you a little bit a small demo of some of the tools that we are building in this area. So let's get going. So when we talk about vulnerability, the first thing everybody thinks about is a CV, and I said a CV as I started, and that makes sense. So what exactly is CV? So it's a program that started, I think, in 1999 with an idea to have like a centralized program to disclose software vulnerabilities, right? It's maintained by the Mitre Corporation, and the whole program contains a lot of partners that are usually called CNAs, CV numbering authorities, companies and organizations that are authorized to assign CV IDs and publish records about them, right? So the next thing is, so what consists of the CV? I already mentioned the ID, and I think that's one of the main goals, is to have this like a common identifier for a certain vulnerability where everybody can talk about them. You probably all see CV in the format of CV dash a year dash the number. So one first thing that can be a little bit confusing is that this year is basically a year when that CV was assigned, right? But the CV actually can be published years later. So you might get like a CV dash 2017 something and thinking something is very stale, but no, it's actually released last week or something like that. So first thing to have in mind, right? Beyond the plain ID, CV contains a CV record, again published as a first, so to say, analysis by one of the CNAs, and the CV record is just contains some information. It's a brief description of the vulnerability, and references to the products and further advisories that are related to this vulnerability. It can contain also additional metrics scores that we will mention a little bit later, but it doesn't contain the full technical analysis, all the information about patching and exploitability of the said vulnerability. So this is just like a first known, so to say, information about particular vulnerability. Vulnerabilities are published into a CV list project. So from where they are picked up by the different vulnerability databases used by different tools, so scanners and software supply chain security tools, as we will see later on. Today, it's a super nice that the CV list project is actually a GitHub project. So all the changes, all the new updates, all the new CVEs and updates are very transparently and version controlled entered into this central source of truth, so to say. The CVE project also defines a schema, and as we can expect, the whole structure of the project is indexed by the year and later on by the if particular year and year. These days there's a lot of new CVEs. They are additionally indexed by the first or first two numbers of the CVE. And as I said, like the schema represents basically this original CVE record, which contains basic metadata, so description, references, metrics, and products that we know at this moment being affected by the vulnerability. Yeah, so that's first thing. So now we have like an ID. We know what we are all talking about. We have basic description, but the other important part, everywhere you see a vulnerability, there's a score attached to it. So this is a critical, or this is a low priority, and things like that. And the scoring system also developed over the years by the CVE project, and it's called CVSS, Common Vulnerability Scoring System. And it's a system designed to attach like a number, score number to the vulnerability from 0 to 10, meaning, you know, this is nothing to this is super critical. And, you know, it's used for us to, for the product security teams to prioritize work on fixing and patching the systems, right? There's also a term called severity, and it's basically mapping of this score basically to some more human related term, like you know, low severity, high severity, or critical. So this will something that you will usually see at the first point when you start looking into a CVE. Here's a brief history of the development of this standard. Basically, only after version 2.0 was released is that CVSS scoring was starting to get majorly widely adopted in the community. Today, mostly 3.0 and 3.1 scores can be found in CVEs, and starting late last year and maybe this year, the CVE 4 scoring schema is more used. But it's not uncommon to see CVEs with multiple scores but basically only in different versions. So the CVE have this scored by the version 2 and this scored by the version 4. And as we will see in the moment, the whole point of this evaluation of the CVSS scoring is to be more detailed about what we are describing and basically better describe severity based on different characteristics of the vulnerability. So you can often see that maybe according to version 2, this is like a high severity, but then according to the version 4, it's medium. So because the more details have been considered, as we will see in the moment, right? So let's talk a little bit about version 3, because this is the most widely adopted at the moment. So every score have 3 basic categories. So there's a base score, so basic characteristics of the vulnerabilities we will see in the moment. Temporal score is how this vulnerability is changing over time, right? So are we sure about the sources? Is there available exploit that can automate this vulnerability or not? That can all affect the score. And finally, an environmental component, which tell us how these scores applies to a certain environment. can its severity be lower or higher depending on different environmental settings. Just to get you ideas, so how this goes. So for the base scoring, so what's important, like attack vector, right? So is this vulnerability can be exploited using the network, or someone needs to have a physical access to the machine to do something? That's two very different things. Is the perceived complexity of this vulnerability low or high? So is it super easy to exploit it, or it needs to be super complex? Does user need to interact with the system to be to do it, or does this user then need to have some special rights? That all also depends on the score. And then in the end, C, E, I, and A, like how this vulnerability can affect this and subsystems of our whole software. So can somebody use this vulnerability to mess with the confidentiality of our data, of integrity of the data, or maybe impact the whole availability of the system, right? And that's basically the base score, right? So then temporal metric group basically then says, okay, we know that somebody is already exploiting this, and there's maybe demos and even the code available for this. And then environmental is somebody can modify these base metrics and add more things to it based on their own environment. We will see a little bit more details later on. So then how it works? There's a math, basically some coefficient added to each of these metrics, and depending on all of that, the score is calculated. So on the official CVEs pages, you can find the calculator. You can play with all these options, and you will see different scores. But also you can find a lot of examples there for existing CVEs with a description, and then an explanation of how people are evaluated that description to actually score a particular vulnerability. So there are a few shortcomings of this system that people figured out over the years. First is that most of the people only use the base scoring because temporal weren't precise enough, so it basically haven't been used. And as these standards evaluated with the softwares, it was only applied to IT systems, so there was no any concepts and concerns about like OT systems, like IoT systems, healthcare, industrial, and things like that. And people were questioning the math behind all this, which brought us to the CVSS4, which tried to add some more granularity in the base metrics. They basically also defined that score. You need to show if the score is only showing the base metrics, or it's a combination of base plus threat metrics. And added a new supplemental metric group that added additional metrics that can score vulnerability on top of the safety, for example, physical safety of the people, if it can be affected, but also add us some new ideas about like how automatable is the exploiting of this vulnerability, and for example, even the complexity of the recovery. Is it also automatable recovery, or it needs to be manual, and things like that. And improved math behind it, right? So this is basically the new 4.0 diagram, right? So I took only one example just to show you these differences that I'm saying. for this particular CVE 3.1 version, it says it's 8.1 score. In the same base scoring, the 4.0 will give it 7.7. But if you take a look at the base plus threat metrics, it's actually 5.2 score for this particular vulnerability. So okay, now we have a identifier, we have a brief description, we know how important this vulnerability is, right? So we're talking that we now need to say what particularly this vulnerability is affecting. And that's one of the, yeah, it's not as easy as it sounds in the first place. So it probably can be a session on its own about identity of the software components. But we will talk about two things today, CPEs and pearls. So CPEs is the first standard that emerged with the CVEs, called Common Platform Enumeration. And it was the first attempt to provide something to enable us to consistently identify application operating systems and hardware, basically. So this is the CPE 2.3 format, and you can see it's basically a column-separated values. The only interesting part is this part value that, depending on the value, addresses like operating system, hardware, and applications, and that's basically what's, so to say, early 2000s systems basically were, right? And then you have an identification of a vendor, of a product, and particular version and subversion, so to say, of this product. So a couple of examples coming from Red Hat. So Red Hat Enterprise Linux in version 8.4, or you know, so to say, product of it is a server release. This you can see coming with the O as an operating system. You can use it to basically identify applications and for example, open source packages like Apache HTTP server, but it's not ideal, right? So for that reason, it's not that perfect for the world we are living today, the world of GitHub and millions of open source libraries. And that's where the new standard, the pure package URL was introduced a couple of years ago, I think, which tries to use like a URL-like schema to identify particular software packages, and more focused on the open source ecosystem. So as you can see, the type is basically ecosystem, so you can have Maven artifacts or Golang artifacts or RPMs, or Docker containers, whatever. Behind it goes like a namespace, the organization, right, and name, similar to the structure of the GitHub repos that we have today. Then version, and basically then an unlimited number of qualifiers as we can have in HTTP or any other URL specification, right? So where does this lead us further on, right? So now that we have all our software components identified, there's more and more push for us to build SBOMs, or software build of materials, for our products, right? And there are more, but in a simplified thinking, it's about a list of all dependencies that we are using in our product, right? So the idea is to be machine readable. We want to automate everything, and for that we usually use pearls to identify all the open source packages inside of it. Today, even still, you can use CPs on more higher level, basically to identify the whole applications or things like that. So you can say the Fedora stuff is using all these packages inside of it, right? And vulnerability scanners are nothing new. there's a lot of things going on, yeah, for ages. But the whole idea with the software supply chain security these days is to try to shift left all these dependency vulnerability metrics in the end. So we want to be sure as soon as possible that we are using dependencies that are not vulnerable or not critically vulnerable, and being able to see that immediately while doing coding or building, right? We talked a lot about the CVE, and as the CPs, like it's a good program, it's super valuable, but it doesn't fit perfectly to the world today of open source stuff. So that's where the open source vulnerability or OSV effort coming in, started by the Google. Thanks for doing that. And it basically tries to push the game forward and to better support people who are maintaining open source softwares to be able to much easier provide advisories for their packages, right? Currently, the OSV consists of two things. One is the OSV schema. It's similar to the JSON schema of the CVE records, which allows everybody to publish their advisories in vulnerabilities in the same format, and it's widely used today. So for example, GitHub GHSA advisories are published like that, RustSec and everything. But on top of that, the OSV project provides an API and a service where you can actually query directly there for certain vulnerabilities or by the package to try to find the CVEs of that particular package. What's super useful is that you can query pearls in batches, which allows us, for example, to parse the SBOM, get all the packages, and in one query get all the vulnerabilities related, for example, for that SBOM, right? So we said that vulnerabilities are not defining only the basic metrics. So that's the next step is then the security advisories. So basically that's other people's opinions about this this vulnerability, right? So it's focused more on providing the remediations and things like that. So this vulnerability needs an upgrade or a hotfix, or it can be mitigated with a configuration parameter or things like that. So all these things are then put into security advisories released by the different vendors and different software companies. And also what's used a lot these days are VEX files or vulnerability exploitability exchange things, which are the documents accompanying SBOMs, accompanying a certain product, saying that yeah, now that, for example, this package is vulnerable to this CVE, but in my context, in my product, it's maybe not affected. Maybe we're not using the feature that's vulnerable, or maybe that configuration thing that enables this vulnerability is not used there. So the product security teams of different companies basically then publish VEX statements saying about all these vulnerabilities we know about packages that are in our product. You know, maybe there are 20 of them, but after our prior triaging and everything, we are now saying that, you know, we are vulnerable only to 2. Others are already fixed in some patches or are not applicable in the product in our environment, right? So there's a lot of work around the VEXs. So basically the major SBOM formats today, CycloneDX and SPDX, are now starting to support VEX statements directly in the SBOMs, which is good. But there's also VEX-specific formats like CSEF and OpenVEX that are used today. So where does this bring us, right? There's like a lot of sources of information, and you can see you can do what I said, like you can scan your SBOM directly, or you can parse it, get the pearls, and then query OSV. But we develop a project called Trustify that will try to do a couple of things. First is the SBOM management. So for all your software products, we will try to ingest and keep all the versions of your software SBOMs over the time, making it easier to query what packages are inside and what, for example, licenses are used. But also we'll try to aggregate all this data. So the CVEs, the OSV databases, the CSAF repositories, and only for the vulnerabilities, and try to, in a single application, provide like a security profile of different SBOMs and security products, right? It's not only about vulnerabilities, so the whole software supply chain world is made of all other metadata, like licenses and attestations and things like that. So all these things eventually will be ingestible and queryable in the software. And we try to provide a nice UI and API to consume all this data. So let me show you a quick demo. We don't have too much time, but just to get an idea how this all can work. So this is the dashboard. You can browse your SBOMs. I have just a couple of examples here. You can see, for example, for each SBOM easily being able to search and find all the tools. So maybe tomorrow when you hear about another log4j with this version of this package, you can easily query and find all the SBOMs you have in your system that contain this library. That's the first step. But the other step also is that based on all the sources that we can import, we can automatically figure out which packages in which SBOMs are affected by different vulnerabilities. And you can quickly, we have this notion of importers where you can define all these sources of the different data sources about vulnerabilities, advisories, and other supply chain security metadata. All this also, OpenSSF, if you're interested into this topic, OpenSSF is a good place to start looking at it. There's also a project called WAC within the OpenSSF that tries to do the similar thing, like Trustify. And I think I can say publicly now, very, very soon, we will join forces to build a single community that will try to build this kind of, we call it like a knowledge graph about software supply chain metadata related to the software projects and components. And that's it. So, is there any questions?
Hello, thanks. I just wanted to ask, I'm not sure, does the Trustify also generate the SBOMs for you, for the open source project, let's say, or do you need to provide the SBOMs?
No, yeah, currently Trustify just ingests, so the question is, does Trustify generate SBOMs for the projects or not? So at the moment, no. So we're just importing SBOMs. We usually use, there's a lot of projects that are now generating SBOMs. One usually used is SIFT. So you can generate with SIFT SBOM in both CycloneDX or SPDX formats and import it in the Trustify. So what we support is that we can automate data. So for example, CSAF repository can be used to store SBOMs as well. So the Trustify will automatically, try to reach that or the GitHub repo where the company can store or other these kind of object storages, and we will just import them and parse them, and then get all this information in a searchable way in the system.
Hi. I'm curious, especially with commercial providers of software, how hard or how I'm curious if they want to share the details of their software, like what packages they use, the SBOMs. How hard is it to get them to share the inner workings of their software and the tools they use?
So the idea is, the question is for the commercial producers is how hard is to share all this information, right? So if you use any of the popular languages, the tools like Sift would be able to get you all the information about open source libraries that you're using, right? But what drives today a lot adoption about using SBOMs and providing SBOMs are these regulations coming from the government. So you probably heard about CRA, NIST, and US executive orders, where basically the governments will now start asking for their suppliers to provide the SBOMs, right? And then the idea that when that starts being more, more used in the industry, everybody else will try to do it, because it doesn't make sense not to do it, because like we do it for all other industries. There's like a food labels and hardware components everywhere. So if I'm the user of the software, I want to be able to know what's inside it exactly, to be able to protect myself in the future. So it's getting there, yeah. It's early days, but yeah.
So you believe it will come from the government asking their suppliers to do it, and then the spillover will happen over the industry?
That's what's happening today, yeah. Just, yeah, raising generally the awareness that it's a good thing.
I'd like to ask, what can I do as a software developer if someone assigns CVE to a problem that isn't security problem at all?
Yeah.
It happened to me.
Yeah, so the question is what to do if you're a maintainer of the open source software, right? And somebody, yeah, I don't have an answer for that, yeah, unfortunately. You probably can reject it, yeah.
Yes, well, there was CVE 5.5 about the possibility that only root can trigger.
Yeah. It's one of the shortcomings of the CV program, and I think it's getting exploited lately. So again, a topic on its own. If you take a look at the graphs of number of CVs assigned per year, it gets, it gets like this.
I've heard that the easiest way to do that is to become the CNA, then you can reject them.
Yeah. Yeah, so there are a lot of discussions about alternatives to the CV program. One is this. The other is the problem with the funding. Everybody who if you track the technology news, you heard about it a couple of months ago. So, but honestly, I still don't know much about it to talk about it. But I think it will keep going. I think OSV is good as well, because you can release your advisories without being pushed to actually assign official CV. So it's much more flexible program. Yeah.
Maybe you can give some non-legal advice. So most of the managers see just the numbers. They just see their 6 highs, something like that. So they're dicing the thresholds, what's allowed, what's not allowed. And I try as a developer to say context matters. What would be your answer to if you have the same manager say, no, there are just 20 lows allowed in your container, and you have to shut down. What would you reply to that?
Yeah, it's a hard problem. So we don't have. Yeah, it's even get weirder, because you can have advisories for the same vulnerability from these different people saying different things. Like, so basically, what people are saying, this is like a multi-truth world. So there's a lot lot of manpower needs to go into triaging all this and figuring out what actually makes sense and doesn't. I think maybe, so what we will try to do in the future is so this is just the first step with Trustify. We collect all this data and put it in, in a database that we can use, but may, be much smarter about it, how we, maybe some kind of AI to make sense of all this, like, give me the priority, what's easy, what can I easily do, what needs to be triaged further or things like that. And figure out like which advisory actually applies to me the best. Like, if you're using Red Hat products, maybe you should, give priority to Red Hat advisories instead of GitHub ones. Or I don't know, but we're still not there, right? So we're now like this collection and easily searchable, correlating things, but definitely something that we want to look in the future. Yeah, I think that there's a lot of space. Yeah, to do this, because as far as I can see, most of the people are doing this manually today, and it's very, very time consuming. Yeah. Okay, so we are out of the time. So thank you, folks.